Okay, so now let's have a look on to the question number 19. That's of 5 mark, and this question is from the chapter Light. Let's read it for more clarification. This says an object is placed at a distance of 60 cm from a concave lens of focal length 30 cm. The first part of the question wants us to use the lens formula to find the distance of the image from the lens. The second part of this question wants us to list 4 characteristics of the image formed by the lens in this case, that's nature, position, size, and we also need to mention whether the image is erect or inverted. The third part of this question wants us to draw the ray diagram to justify our answer in part second. So let's solve this question. So in the first part of the question, we need to find out the image distance by using lens formula. Okay, so here you can see I have already solved it. So first of all, in the exam you are required to mention what is given to you in the question. So you are given a concave lens of focal length 30 cm. You need to keep this thing in your mind that the focal length of a concave lens is always going to be negative. So you need to mention there f is equal to minus 30 cm. Object distance is 60 cm, and you are again going to put the negative sign in this case because we know object distance is always measured opposite to the direction of the incident light. Further, you need to put this formula, that's lens formula. When you will substitute the values in this formula, you will be able to find out the image distance, which comes out to be 20 cm, that is minus 20 cm. Okay. Now, in the second part, you need to feature or list the characteristics of the image formed. So you need to mention the nature. Now, we all know that the image formed by the concave lens is always virtual and erect. So image is virtual. Position is 20 cm from the lens, and that too on the same side as the object. Okay. The size of the image is going to be diminished. Now, if we talk about whether the image is erect or inverted, I have already mentioned it that it's erect. Further, in the third part of the question, you need to draw the ray diagram to justify your answer. So here, this is the concave lens, this is the optical center of the lens. Now, object is placed at a distance of 60 cm. This is the focus. So, this is the focal length, which is 30 cm. This is a ray that is parallel to the principal axis. So, it will appear to be coming from the focus after the refraction through the lens. And this is a ray that is passing through the optical center, so it goes undeviated. So when you will take or draw this back, these two refracted rays are intersecting at this point B dash. So this A dash B dash is the image of this object, which is diminished. This image is virtual, this image is erect, and it is formed at the distance of 20 cm from the optical center of the lens. So I hope if you have drawn this diagram and if you have mentioned all these things, then you are going to get the complete 2 marks for this part of the question. So I am now just going to tell you the marking scheme. So this part was for 2 marks, and you are going to get the complete 2 marks only if you will mention each and everything in your diagram. Okay. Now in this part of the question, you were asked these 4 things, and you are going to get half mark for each of it. Half mark for telling the image is virtual, half mark for telling the distance of the image, half mark for telling that the image is diminished, half mark for writing that it's erect. So you are going to score 2 marks for this complete part of the question. Now you will be getting 1 mark for solving this part 1 for the question. You will be getting half mark for writing this lens formula, and you will get final half mark when you will solve it and you will calculate the image distance. So this is how you are going to score 5 out of 5 for this particular question. I hope this solution of this question is very clear to you. Now let's move on to the discussion for the next question.